my dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about union in C. Well, in today's video, we will discuss something about structure padding. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Structure padding, as the name itself tells you, it is quite a very simple concept that what everyone should know. So when I say structure padding, it refers to the insertion of some additional bytes into a structure so that we can satisfy the alignment requirements imposed by the hardware architecture or compiler. So this happens in structure. So when we have plenty of members in the structure, we should know how to arrange those members in a proper alignment. And this alignment has to be taken care by the programmer itself so that the memory can be managed well. Well, nowadays memory management is taken care by the compiler automatically. But in some scenario, there may be some complexity wherein which the memory arrangements and alignments will go wrong. So we should know what we have to do with respect to have a proper alignment of structure members. So here, what happens? This padding is the process of adding some extra bytes. And this addition of extra bytes will be taken care by compiler itself. So what happens? When the padding is added, it ensures that every member within the structure is properly aligned in the memory. So which can improve the performance and efficiency of the CPU. So when I say you have some members and the arrangements of the members are not done properly, it consumes more memory. So here, historically, we have to talk about how the memory was accessed. Historically, the memory was accessed byte by byte. It was byte addressable. But now, it is word addressable. So what is this byte addressable, word addressable? Let us understand this with a small example. Then actually we can understand what this padding is. So let us understand the memory allocation of this structure. So we have a structure by name test with the members say character A, int B and character C. And if I just say what is the size of this structure? So I can just say size of S. So how much size it is going to print, let us see. So as we all know, character takes 1 byte and int B with respect to, if I just talk about 32-bit machine, say 4 bytes. Then again character C takes 1 byte. So what I can say, it is 4 plus 1 plus 1. So it is totally 6 bytes. But this is in the case of byte addressable. If this is byte addressable, then what the CPU will do, in one cycle, it can fetch only 1 byte. So if I talk about the integer, character, okay fine, it is 1 byte, I'll easily fetch. But if I talk about this integer which is consuming 4 bytes, if it is byte addressable by the CPU, in one cycle, it will fetch 1 byte. So in order to fetch this complete integer data, it has to have 4 cycles. So the efficiency and performance is low. So here it has to have 4 cycles to fetch this 4 bytes of data. So it has been improved now. Now we have word addressable. So what is this word addressable? Usually this word addressable is machine dependent. It depends upon the machine. If it is 32-bit machine, then one word means it can access 4 bytes at one stretch. If it is 64-bit machine, then one word it is accessing means it can access 8 bytes at one stretch. So if it is word addressable, then if I want to access this integer data in one single cycle itself, I can access this complete 4 bytes of data. Whereas in byte addressable, it used to take 4 cycles to fetch the 4 bytes of data, because byte by byte it has to access, so 4 cycles to access 4 bytes of data if it is byte addressable. But nowadays the processors are word addressable. If I say in 32-bit machine, one word means it can access one word. It is, if it is a CPU is accessing one word of data means 4 bytes of data will be accessed in one cycle. If it is 64-bit machine, then if it is accessing one word means it is accessing 8 bytes of data in one cycle. So now what happens? In this structure, the memory will be padded with some extra bytes. So what happens now? When I say character, 1 byte, and then I say it has to access integer, but extra bytes will be filled here. So let us see that representation now. So what happens here? Look at this memory representation. When I say it is character, I say it is 1 byte. But it is word addressable means I need to say it is 4 bytes. Actual saying A consumes 1 byte of data. So remaining 3 bytes will be padded. This is padding bytes. So who is going to fill this? The compiler automatically fills this padding bytes because this is one word, this is second word, and this is third word. So let me talk with respect to 32-bit machine, means one word equal to 4 bytes. This is one word, second word, and third word. So one word means it is actually 4 bytes. So when the CPU access this one word, it will go to this particular word and access 1 byte of data, and the remaining 3 extra bytes will be padded. So the memory is getting wasted here. So padding bytes will be inserted automatically, so that when the CPU comes and fetches this one word, it has to fetch the complete 4 bytes. So extra 3 bytes will be added here. And this task will be done by the compiler itself. We, the user, will not fill any bytes. The compiler fills extra 3 bytes so that it can suit the requirement of one word, because one word is equal to 4 bytes. So here character takes 1 byte, the remaining 3 bytes. So it is 4 bytes, 1 byte character will take, the remaining extra 3 bytes will be added so that it can say it is one word. So it is 4 bytes. Then followed with that we have integer, it is as usual 4 bytes, so it is one word. Then again you have character C. So A, B, C. So A means it is 1 byte, now it is B, it is integer, so 4 bytes. So here it is 4 bytes. So need not to fill extra padding bytes. Then here it is C, which takes 1 byte, but extra 3 bytes has to be padded. So padding bytes are 3 bytes so that it can be treated as one word. So if I just say print the size of yes, how many bytes it is going to consume? It is 4 plus 4 plus 4, it is totally 12 bytes. So the memory is getting wasted. So memory is not being utilized efficiently. How to overcome this? So as a programmer, we should know how to align the data or how to create the members. So these data alignment will be done by the compiler itself, because depending upon the architecture of the hardware, CPU architecture, it is going to fill the bytes. So now if I talk about 32-bit machine, it is 4 bytes. Character, it takes 1 byte, remaining 3 bytes, it is padding bytes. So it is going to suit the CPU architecture. So the compiler is going to fill the padding bytes so that the data can be aligned properly. So when I say one cycle of CPU, it will fetch this character. Second cycle, it will fetch this integer data. Third cycle, it will fetch one more character data. So I can just minimize this padding bytes by rearranging this members in increasing order. If I just create these members in increasing order, then I can somehow minimize this problem. So what I can do here, I say it is character A, character C, then integer B. Now what happens? It is character A. So characters can be allocated anyway. It is 1 byte, so it can take continuously. Character A, it takes 1 byte. Character C, it takes 1 byte. The remaining 2 bytes will be padding bytes. Then we have integer, it is 4 bytes. This is first word, this is second word, and this is not required. So what happens here? Character 1 byte A, character C 1 byte, remaining 2 bytes will be filled as padding bytes by the compilers. So totally it is 4 bytes, and for integer it is 4 bytes. If I say print the size of yes, it is going to print 8 bytes. So the programmer should know how to create the members. So if I create an increasing order, I can minimize the padding bytes. But nowadays all these filling of padding bytes will be taken care by the compiler itself, and there is no problem to have enough memory. But even then there may be some complex situations wherein which we as a programmer should know how to have the structure members. So if I create structure members in increasing order, I can use the memory effectively. But you also have a concept of packing this address. So how to pack that addresses, padding bytes, means we need to include a special definition section. We need to have a section wherein which it is going to pack the memory. How to pack that? Let us see in the next video. So hope you have understood with this structure padding. Well, structure padding is done by the compiler itself. We, the user, will not do anything. Depending upon the hardware architecture of the CPU or the compiler, it is going to do the padding. So if it is 32-bit, 1 word length, so for one cycle it can access 1 word, means 4 bytes at one stretch it can access. If I say character 1 byte, the remaining 3 bytes will be padding bytes. It goes on like that. So memory utilization has to be done effectively. So as a programmer, we have to do the data alignment. And these data alignments will be done by the compiler itself. And we should know how to arrange these data members so that the data alignment of the compiler will be done neatly so that it can consume less amount of memory. And you have some extra definition section where I can pack this address, that we'll see in the next video. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.